Kimgus was interested in that whole content chip concept I did for MFCS, and I've decided to basically make a chip that was just a giant MFCS content chip, however without relying on MFCS, so it could do rendering itself. You can think of it kind of like EGP, but in Starfall, sort of, I guess. And I've decided to call it Mirage. So through iteration, hopefully I learned a little bit from the last time I did sort of like a programming log of a chip. But this time, instead of just like leaving my recording running while I program, I've been doing a bunch of recaps and also sometimes remembering to turn the recording on when I come across a problem. With that being said, the video is still really long, and hopefully you learn something or find this useful, and otherwise, enjoy. Okay, so for the first phase of Mirage, it was once again overcoming blank page syndrome. So rather than trying to chase down how do I do everything at once, I was more interested in, okay, how do I recognize someone getting in a chair and whatnot. Now we go through like the stages, and by the end of the first stage we basically have a working image class. If you know of you know what a class is. If you don't worry about it. But basically it's a way we can make multiple sort of like graphic textures and like rendering objects, so you can have like multiple panels and things like that. But that's where this first phase ends up, and realistically this is all you really need to know. So I want to do this thing where there's going to be an interface and there's going to be a core. So basically this requires includes. Now the way this works is the interface includes the directory to the core, and it requires it. Now this actually has a return, but don't worry about it. And there's this debug message function. So how this actually works is if we go to the core, see I have some things I'm not using yet. Server client, because it's going to be shared, and at the very end of the file it has return Mirage, and that's the table that's going to hold a lot of functions, and one of those functions is debug message. So basically when I include the core, I can just use require to actually run it and get my function in this case because I'm returning it, and I can call a function on it. So in this case, debug message, all it does is prints hello on the server and client because it's shared. So let's see. So yeah, the blue hello message is on the server and the yellow one is on the client. And that's where I'm at so far. Just some groundwork stuff. Overcoming blank page syndrome. Okay, so as you can see from the interface, I have done absolutely nothing except stop using this debug message thing. However, if we come to the core, there's some things that have changed. So I've added a couple of little objects that I like to do so much. So I have the manager. This is going to be on the client and server, but right now I'm just doing this on the server, and also an IO unit. So look at that IO unit first. So I've given it the description, create and deal with outputs. It should be inputs and outputs. But anyway, what this thing does is, well, you can add inputs, add outputs, and actually create the inputs and outputs. So I just like to have a little easy to use functions to deal with this. So I mean, yeah, that's it. Just these three functions. So to actually use this, I have a little test going basically. So I have the manager, which is going to, well, manage things, but my test is I'm basically adding a chair that is of type entity, and I'm telling it to go ahead and make those inputs and outputs. I don't think last time I mentioned for the camera control emulator, but I am actually calling the make IO or do inputs and outputs before running initialize, because normally I do some extra setup and initialize after making the outputs. But in this case, initialize doesn't do anything. So I'm going to spawn the interface, and because the core is included in the interface, now when I go to wire the chip, I have a chair input. And unfortunately, that doesn't really do anything. I mean, I guess it recognizes the chair. Yep, there we go. It recognizes the chair. It doesn't really do anything with it though. So, but next I want to add, well, I want to render something on the driver's screen. Alright, we're back at it again. Now I know I said I wanted to add like drawing a basic square, but I haven't done that yet. So nothing's changed in the interface. So let's just go to the core. Admittedly, I have done some copy pasting. You can see there's this operator thing that I just stole straight from the camera controller emulator thing I did. But yeah, let's look at it here because I did have to change it. So you can see in the manager, I'm now using its initialize and make IO function. Nothing's changed with the IO unit, so that stays collapsed. Now, what the operator does is it basically keeps track of who's a driver and like notifies when someone gets in or out of the vehicle using the player entered and player leave vehicle hooks. And yeah, it just sends net messages to the client with the ID chair event. So one thing I don't think I described I wanna talk about is that, like I said, I like using objects, and you can see this do in scope. So you have some local variables, even some local functions, but basically anything attached directly to, let's just say, operator, because operator is defined all the way up here. I can do this. I can do, initialize, make IO, because those exist as part of the table. However, anything that is local in here, like the driver, like this, even this whole function, you can see it's not attached to the table like the make IO and initialize functions are. All of this stuff is basically invisible everywhere else. It can't be gotten. So I can't get the driver, I can't get the chair entity anywhere else. It doesn't see it because it's sort of sectioned off in here. So basically anything attached directly to the table I can get, which is why I have a getter down here. Now, if you don't want to use setters and getters, you could also, instead of using the driver like this, what you could do is you could do this. And this will work just fine because this is attached directly to the table. But I prefer to use setters and getters. Here, yeah, setters, I suppose. Technically, setters don't really exist in Lua or Starfall, but yeah. But yeah, anyway, in initialize, we begin listening to leaving and entering the chair. And so the function we use there on enter chair. Someone gets in the vehicle, we set the driver to be the player. Someone leaves the vehicle, we set it to be null. And regardless of whether or not someone enters or leaves the vehicle, we are going to sort of ping them. And of course, if this is the wrong chair or what have you, we just don't do anything. That's what the return is here for. Okay, so we have that on the server. So it recognizes when someone is getting in or out of the vehicle. Let's look at the client. So you can see I begin to put down a manager on the client, and this is just a test. So yeah, here we go. We have the receiving function, which is called in pre-initialize, which is also called down here. But all that's happening here is we're basically beginning to listen for the network message, and every time that message goes, we're just gonna like print a message depending on if someone's getting in or out, which is notated by the boolean we get. So when I get in the chair, it's gonna say this. If I leave the chair, it's gonna say this. For some reason I said I modified the chip. Anyway, there we go. You got in my chair. You left my chair. Said. But I think now with that being described, I would like to actually render, something on the screen. Now that we actually have someone getting in and out of the chair. And as you know, rendering, you can't do it on the server. You have to do it on the client, which is why we have to network stuff. But so far, we're not really networking a whole lot of anything, just if someone gets in or out of the chair. Alright, status report. So, nothing's going on any different on the server. However, on the client, I've added this thing called renderer, but more on that in a second. So I messed with the client-side manager some. mostly involving the initialize function. Not too much going on with that, but on the server, I want things to start up immediately. That's fine. However, the manager, immediately I want it listening for the chair event. However, I don't want it starting up until somebody gets in the chair for the first time, which is what this whole like pre-initialize runs. But then initialize waits a bit, or like waits till someone gets in the chair, and at which point it can't initialize again. Anyway, that's not important. So you can see in the onInterChair function there, it tells renderer to set itself active. Well, depending on if we're boarding or leaving the vehicle, that is. So let's take a look at the renderer. So here we go, renderer drawing events. We don't have any events yet, but I wanted to do my little rectangle test. So let's get something drawing on the screen. So there's the set active event, which runs when someone gets in or out of the chair. Someone gets in the chair, we want to enable the HUD and add to the draw HUD event, or hook, not event. But basically you can treat them as the same thing. Okay, I have this draw test function, which gets defined here, gets added to the hook. And so this draw test function, all it's doing is, well, drawing a rectangle at 512 by 512, that is 512 by 512. This is the position from the top left, and this is the size, width and height, and that's it. There's nothing particularly flashy going on here. You can see it enables my HUD when I get in a chair, turns it off when I get out of the chair. So what I want to do next is see about doing some sort of system for actually, you know, making use of the interface and drawing, or like basically messing with some settings to draw particular things and whatnot. So that's up next. All right, here we are in the interface, and nothing has changed again. In the core, nothing has changed on the server. I did put a few more comments on things like, oh, this is on the server, this is shared, whatnot. So on the client, I began adding some events. Well, really just one, renderer draw. And I also have another like definitions thing down here, but I haven't done anything with that yet. I did remove the little demo like testing from the renderer, so instead we just have onDraw, and all that does is run our custom hook. So anything that's subscribed to this hook, whenever this runs, like all of those things will run. So that's kind of nice. So I've begun adding something I like to call a pseudo class. So normally my objects look like this. So we have something called image here, and it's going to have some functions attached to it that everything else can see. Now, this is kind of weird because the way this works is that there's objects inside of this object, or like this is like right here, this is a pattern for objects that this thing is going to keep track of. So you can see instances, well, that's just a table, that's gonna be how we keep track of it. And you can see we have an add instance function, and that's going to take in a different table and put it in the instances function here. So normally I just have one singular scope or do end section. However, here I basically have two to differentiate between an instance and like the rest of it. So you can see I refer to the regular part as static because, well, there's only one image add instance function. Okay, so let's look at the instance stuff. So right now, when you do image.create, it's going to make a new table and it's going to spit that table out. Now another thing it should do is call the static add instance function, and we're going to pass in image. So what's going to happen is every time you call this function, a new image is going to be made, and it's going to be stuck in the instances table to keep track of. so we can do things with it. Actually, I don't know if I need to keep track of the instances, but I'm gonna do it anyway. So literally nothing happens. Yeah. However, I'm going to start adding a bunch of functions to the instance, and it might get kind of confusing, but hopefully we'll have a practical demo of how that works. Okay, I know I'm hovering on about it, but I kind of want to drive the point home. So, the only thing that's changed is in the manager's initialize, so the function that only runs one time for the first time whenever someone gets in a chair, I'm calling the images initialize function, and that's it. So all eyes on the image. Well, let's look at the instance first. So, as you know, we create an image and we stick it in the instances table. However, now I have a property on the image, the draw function, which is going to start off as empty, our little template function all the way up there. It doesn't do anything. You can see I've added a descriptor or like comment that says methods. So just like the other objects, these instances, the image instances, are going to have functions attached to them. And we have one function, or method you could say, that's just draw. And what this does is it calls the draw function. That sounds really dumb, but, well, it's a function to call another function. Don't worry about it too much. But anyway, you can see now I've added an initialize function here. It's going to add a different function to the renderer's draw event or hook, I suppose. And we'll take a look at that function in a second. However, I wanted to show you what I mean with creating instances. So you can see test1 equals image.create. So remember, anytime you call this create function, it's going to return an image. So you are getting a table back. And we have access to the draw function property. So I stuck this directly onto the instances table. And this is the draw function, what was it, property? So we can basically access that and give it, well, in this case, a function. And this is the same as last time. It's just a yellow rectangle, or square, I should say. However, I also have a second one. Once again, doing image create. I changed the name. Changed the name because I don't want this to be overridden or anything. Actually, no, it won't overwrite because it'll... Whatever. I created a second one and I'm giving it a different draw function. So this is going to draw a black circle. Now that's all well and good. We have these, two images with their draw functions that are unique. Now this is where the other function I gave it comes in handy. So this onRendered draw that is going to run every time the renderer runs that hook from earlier. This is going to loop through all the instances and it's going to call the draw function. That's it. And remember, this draw function just calls image draw just calls the draw function. Again, it's kind of weird having a function in a function, but I plan to change this later, which is why that looks like that. So notice we are using I pairs and not pairs. The reason we're using I pairs is because this is a sequential array, because we're using table.insert rather than setting an index with like a string or something to something. For that we'd use pairs, but we can use I pairs because it's sequential. So remember, you have a key. I've discarded the key. Normally it shows up as k, for example. Oops. But I've discarded it, so underscore. And the value. Now the value I called image because, well, that's what is going to be in instances. I could call this whatever I want. I could call this, I don't know, object. But I have to use object here. It's just easier if this is image because, well, I could just copy paste. That's the only reason. So what we should see is a yellow square and a black circle at whatever coordinates. And yeah, we can update it. That's fine. And there we go. So it's very easy to, again, add instances if I really wanted to. So let's call this test 3. And this is going to be a red circle that's a little bit smaller in the same spot. So we'll do 128. Yeah, check that out. So basically we created effectively a pseudo class. If you don't know what a class is, it's, well, you don't have to worry about it, but yeah, kind of neat for certain things anyway. All right, now to really drive the point home, we are currently looking at the interface, and the interface has changed a bit. So I have this thing called art, which the name doesn't matter. I made it a table because we're going to be storing instances, or actually making instances, and I want a variable to manipulate it before creating another instance. So this is the same thing. You can see we still have access to the draw func for both of these. And I know we're using the same variable, however this makes two honest. Two different instances honest. So observe Mirage create instance. I'm sorry, create image. Let's go ahead and take a look at that. So remember our old debug message function? Well now, and this is on the shared as well, so it runs server and client. Now we define a create image function, which returns an empty table. Now you might be wondering, why does this function exist? So on the client, we redefine that function as returning an instance from image.create. We're not returning the function, we're returning the thing that the function returns, because you remember image.create returns a table, which is our little image object. Whenever we call the create image function in the interface, it's going to try to call it on the client and the server because this is shared. So if we try to call this function and the server doesn't have a copy of the function that returns a table, the chif is going to break. So we define basically a placeholder function on both that just returns a table, an empty table. So the server won't like cause the chip to break, and we redefine it on the client. Okay, so those are like redefining certain definitions that only the server or the client has access to, and not technically both. So as you can see here, it's basically the same thing we were just doing. We just have some draw functions that draw a bunch of stuff or whatever. In this case, only one thing each because well, I don't want to spend a bunch of work on a bunch of time on examples. So nothing's changed in the instance, junk. Now in the rest of the object, the static object, the big image as opposed to the little image, I basically, the only thing I did was got rid of our example where we make two images here because I want to make the images in the interface. So it's like user accessible and all that crap. So if we refresh the chip with this and run it, there you go. I have two images, well, quote unquote images. And I can even add a third image if I really want to, and we'll make this 450. Well, actually we'll make it 400 by 200, and we'll make the color red. Actually, no, that looks cool. We'll do that. There we go. Well, with all that being done, I would like to make a few modifications to, well, yeah, image, and the image classes, I suppose, the instances. But I guess we can talk about those when I'm done with that. Okay, so this quote unquote middle phase, which is really should be the end, but so we do a few more things to the actual drawing, the image drawing, make it accessible to the interface, because remember this is a chip that's including another chip that is the core. So yeah, clean up image, there's one function for drawing on the texture and another function for drawing onto the screen, drawing the actual texture onto the screen. Or you could actually use that for drawing if you don't care about performance too much. I would then go, and this is really access to requirement for rendering, but if you want to make chips fairly easily, sort of like EGP, you need to send inputs to the client. So I added a part, basically auto input networking to send the inputs from the server to the client, so the client can do things with information from the server. All right, day 2 no lean. Here we are in the interface, and things look a little different. And I do mean a little bit. So previously I set Mirage to be equal to the require. However, now I'm having the core output 2 different tables. So you're going to have the Mirage thing. But we also have our SH table, which is where I like to stick miscellaneous settings in. So you can see if I go to the core now, yep, there's Mirage SH. And at the very end, it's going to return both of those in a table. So, I mean, we still have the Mirage stuff. We also have some SH stuff. And you'll notice I have this thing called refresh rate. And also you'll notice in my drawing function, I'm using render.clear. That's interesting. So anyway, refresh rate. So what I've done is if we come to the renderer. Well, first of all, there's a new event, renderer refresh. And basically there is a timer that uses a refresh rate. I give it in the interface and just calls this on refresh local function that's just going to run the event. So everything that's listening to the event, or hook I suppose, is going to run. Alright. So the instance has gotten bigger. Because basically what I'm doing before I get into it is, instead of drawing everything just as is using whatever primitive, I am storing it all in a texture. So writing to a texture and then drawing the texture. So to do that, I've added a local to the instance texture. Well, this is a texture name, but basically a texture because that's how you access your render targets. And that is the name of that texture is going to be image dash the number that the image appears in the array. So I've actually modified the add instance function to just return the output of table.insert, which table.insert, all that does, oh, you can't actually see it, but basically table.insert will return like the number. So it goes like, okay, first time it's going to be 1, second time 2, 3, 4, and that kind of thing. So it's going to be image 1, 2, 3, and so on for the texture ID. And now we have this local function texture right. So we're basically taking the draw func and we're sticking it inside of a texture. Now you'll also notice I have hook.remove render off screen. More on that in a bit. At some point, I'm going to have to figure out if I want to do like permission request stuff, but for now, I'm not creating the render target immediately. So this is how you make a render target. Give it the texture name. And now we have the old draw function and we have a new function, a refresh function. So what the draw function does is it displays the texture. But first we actually have to write to the texture to have something to display ideally. So refresh, all that does is starts the render off screen hook with our texture ID as the hook ID. And that is the thing that's actually calling texture right. So what happens if we want to draw onto our texture? We use image refresh, which starts render off screen. We select the render target, draw our thing, and immediately leave because we're done with it. Okay. So to actually draw the texture, the render target, I am drawing it with a material, and there's not really a whole lot of reason of drawing it with a material, however I like doing that. So you'll notice image reset material and image get material because I've stuck the material in the basically static part, the main part I suppose. you only really need one material, and all these little images can share the same material, so that's why I did it. Yeah, we can see material that create renders or Gmod screen space. That's fine. So when it this doesn't have an initial, well, it does, but we can just do material.create coming out the gate is fine. And there's the reset material. So I was having an issue where if I don't set the alpha, and I want to say texture alpha, I was getting this like black box. I think that's down to the alpha actually. Maybe, I don't know. But this is all what reset material does. It just, yeah. In fact, I could probably do this one time rather than doing it every time I want to draw something, but anyway, don't think about it too much. So yeah, we reset the material, which, you know, set texture alpha, set alpha. We then set the material to that one material, the material in image. Yep, material. And there's a getter on it because again it's local to the image. And then to actually draw it, we have the texture in the material. We just do set texture render target, base texture. I don't really know what that does, but that's what we need. And give it our texture or texture name, I suppose. Kind of interchangeable, I guess. And then we just draw a textured rectangle. So I mentioned these events over here. So there's the old draw event and there's a new render refresh. So to use those, I guess the static, I'm just going to call it the static part of image. Put those there for a reason. But so I've gone ahead and added a onRender refresh function, and you can see that does something similar to the draw. It just loops through and calls, well, that function, just the refresh function. So every so often the image is going to get refreshed, depending on what you set the refresh rate to. Oh, and there's something over here. Yeah, so initialize it when the image, the static initialize happens, it also calls initialize on all of the little instances. So the part that actually creates the render target, remember. That probably sounded very complicated, but the end result is we are using textures to draw our things. And this little demo, so textures are 1024 by 1024 max, so this is the problem we have. I have a big yellow rectangle that's 1024 by 1024, and I have another like peach rectangle that's 1024 by 1024 but offset. If I get in a chair, you'll notice that only part of the other rectangle draws because we ran out of texture space basically. So primarily just a reminder that, well, textures can't be as big as the monitor, unfortunately. Why is there a black screen on my monitor? That's not supposed to be like that. I wonder if this is why. Oh, yeah, that might be why. I need blur, but maybe this. Yeah, that was it. Okay. Okay, now I've done something. So you might be wondering, why are we doing all this extra work to draw a texture instead of just drawing the thing? It works just fine. Well, I've set up a little test, so I've added this thing called constant draw, and I'm gonna set it to false right now. So what does constant draw do? Well, by default it's false, and if it's turned on, it's not going to try to do any texture, right? The little image instance. And also when we try to draw it, instead of again trying to draw a texture, it's just only going to basically call our draw function. So absolutely don't use texture. And we can switch this on and off. Now another thing I've done is I've set up a little like ghetto gradient, and I even have a performance probe here. So this is going to get the CPU time in microseconds. And let's take a look. I should also point out that I'm basically drawing 64 rectangles to make this gradient. Okay, so you can see, yeah, about 400 microseconds. It's spiky, but everything seems to spike. I'm not sure why, but around about 400 microseconds. I should also mention that I was doing this, 20 times a second. Realistically, I only need to do this one time and never again, so it could be even better, but the point I wanted to drive home was this. Let's absolutely not use any textures. So basically, it's going to do this every time we want to draw something. Alright. So I guess we can call that about 2,300 microseconds, which is about 2.3 milliseconds. And even that one is spikier, or it spikes in proportionally, I should say. So the reason we're using textures is basically because of performance. Drawing something every time you need to, or every time in the draw hook does take a lot. Eventually you have to do it, because to draw the texture you're drawing something, but if we're using a texture, we can basically pick between whether we want something to draw really often and the performance, I suppose. Alright, pretend ladies and gentlemen. I've hit my things, but before I show you my things, I wasn't going in to do that on purpose. Let's check out the core. So I cleaned up the image junk a little bit and reorganized it, add some more things to it. But before that, I'm adding the ability for images to be static, because you remember my little gradient, maybe I just want like a bunch of stuff done once and never refresh it again, so I've added an is static. However, because I'm sticking this on Mirage, which is the main table, it's kind of important that the is static actually makes it in there, because that was giving me a bug. Anyway, so yeah, is static, and true or false is a boolean. Also written is a boolean as well. So in the texture right, we just set written to true. I've actually changed the name of some of the functions to make it make more sense to me. So draw texture is the thing that actually renders the texture now. So the draw func is like, do some final adjustments, maybe move the texture's position, whatnot. Refresh texture is gonna be the thing that actually I suppose writes to the texture. So if we go to, yeah, so you can see there's a refresh func now, and that's actually going to be the stuff that we draw, we render, whatever, and that's going onto the texture. Now you might also see this force refresh texture. So I thought this would be useful to have for certain static things. If you want to, like, okay, something happened and I really want to refresh this, I can just call this function. And also you'll notice self in some instances, actually only in the image methods, I suppose, the image, whatever this is, colon? Yeah, I think that's colon. Okay. So what self is it's just referring to the thing that the colon is in front of, so image in this case. Now you'll notice I can't use colon over here because it's just a regular old function and it doesn't have anything to do with it's not attached to the image basically. So self just means I'm referring to the image in this case. But yeah, that's it. So in the on render refresh, on renderer draw, we just renamed the function, so we make sure we actually call those functions and not use the wrong name, because that would be bad. But yeah, let me show you my thing. So I actually put do ends here so I can collapse these, which is kind of a nice thing about the Starfall editor. E2 developers, please. But yeah, I've gone to actually giving my little objects, image objects names. So yeah, gradient, it's static, so that's set to true. And you'll notice, so we have our refresh function, which does all that, render clear. But we actually have to do draw texture rectangle here because I've taken it out of the drawing that's done over here, because I wanted people to be in charge of how they draw their texture rectangles and all that. But without this, you won't actually see anything, so that's kind of a weird move, but I think it makes sense. And I'm not really gonna go over all of this really, but major C's are nice. It's just regular old Starfall code at that point though. And this might look familiar, so this is a crosshair, and this is also static. This comes straight from MFCS. So there's a little shape editor code I copy pasted, and also yeah, this for the most part is being drawn in the middle of the screen. So let's see what all this stuff does. So if I get in the chat, you can see, yep, there's my crosshair. It's a little bit smaller because I set the scale down. And if I look at 0, 0, there's my gradient at 0, 0. And both of these are static, so they're not actually refreshing. So the chip usage should be really, really quite low, like sub 100 microseconds. That's kind of nice. But anyway, that's basically the drawing part of Mirage done. Now what I want to do is, I wanted this to be more than rendering, so I actually wanted it to handle like, be sort of like EGP but for Starfall, or like not quite an EGP emulator, but you know, I wanted it to have enough things done that, you know, we can put crosshairs that are attached to guns and like get ACF functions and stuff like that. But this is basically over half of the way finished, and probably most of the way finished actually. I just want to add some like special input output system that'll like automatically handle networking from the server to the client and then back to the server for outputs. So that's basically what I'm going to be trying to do next, and I'm not sure how to actually do it. It's just thoughts in my head and ideas, but not something I actually tried to do yet. So see you then. Attempt to call force refresh a nil value at 211. Me. Oh, force refresh texture. And you straight up don't work now. Cool. Oh, I forgot I moved that. Okay, well, render that draw texture direct. Oh, yeah, I need to give this something. Okay, so I'll just refresh, and then draw func. Yeah. Draw func equals function int. Yeah, so that's it. Yeah. There we go. You're supposed to be static. Okay, it's false. But it's true. So how could it be false if it's true? Oh, I see the problem here. Right. I see the problem here. I'll make it even aesthetic. I see the problem here. Go away. Okay, this should work then. Yeah. So you should only like draw one time. There we go. It's freaking static. Okay, let's have a look at this. So I have basically more objects. So you can see local f equals Mirage, create input f number. So name of the input and the type. And I'm initializing its value to 0. And over here I have another image that I'm doing stuff with based on whether or not, or based on what f is equal to. Okay, so let's take a look at the code. So let's go to the IO unit first because that's where things have changed. So now the input output unit is a, I guess, class now. It carries its own instances. And this is an input instance. So this is really quite small. All it's doing is adding an input to the chip, and there's a function to update its value. And the way I'm adding this to an instance list is a little bit different. So previously I was using, let's see, for the image. So for the image added to add it to an instance list, I was using basically a sequential add. So table add insert, it's like a sequential array basically. With this, it is different. It is a key value. So it needs to have a name and then the object itself, as you can see. So you can see this is the key. So the name equals, well, object. In this case, whenever I do create input, the key is the name and, well, the object is the instance itself. So, yeah, in this case the key is F, because that's what the name is. Now, I'm down a little bit. So in create IO, I have something that goes over all of the extra input instances, and notice we're using pairs instead of I pairs. So again, this is a sequential array, and not a sequential array, it's a key value array. So we use I pairs for sequential, and just pairs for non-sequential. In the old create IO function, right before actually creating the IO, we just call make IO on the instance functions, which just calls add input, which adds it to an input list. The string and type list anyway. This is getting confusing because there's a lot of lists everywhere, but this function is new, so this is basically what's responsible for networking. So there is a big table input values, and technically I don't need this to be like basically a persist or kept around, but we're basically gonna fill this table up with all of the input values and send it over to the client with an ID of IOU inputs, and we're finally using the get driver function from the operator. So if somebody's in the chair, it's going to send it to them only. And yeah, input values. So we loop through all the input instances, once again pairs, and this time I'm actually using the key, which is name, and the object is the input. So before we send it over, we just call update value, and we basically put it in the input values table. And once again, that's a key value table. Okay, now we have send inputs, but I'm not showing you what this is actually called. So ideally, I would actually have my manager managing things, but I've been lacking doing that on the client, but maybe I'll come back to that later. Anyway, I have a new function on send data, and that's running on a pretty slow timer because it's very easy to tick quota your chip, or not tick quota, break your chip. For some reason, if you send too much networking data, Starfall doesn't like that, so about 5 times a second is what I'm doing. But yeah, what on-send data does, you can see it's just a pass-through. It just calls that send inputs function. So 5 times a second. And that never stops. Let's go onto the client and see. So we got the manager open, come back to that. So yep, we added IOU, or input output unit, to the client. And once again, it's a pseudo class, so same create input function. It's a table that has a singular value property in it, and we're adding it to a collection of instances the same way. And once again, this is a key value pair, so we're just gonna ignore all this for a second. But yeah, you can see my add instance function, it's again a key value pair. See, I have a receive function, so net.read table is the table we're looking through, and once again we're doing pairs. So remember, the name, or the key, is going to be basically the name of the input, and the value is, in this case, actually going to be the value. Because remember, before, the value is not the object itself, but like the value on the object. So for all of the client side instances, we're just gonna get that particular instance. So input instance is name to get the input object, and dot value equals the value we're getting from the networked table. And notice this is the uppercase value, this is a lowercase value, because this is part of the for loop. Okay. So what this is I was thinking that there would be a possibility that you start off a chip and you want to reference something, and initially it doesn't exist, so it'll break your chip. So what defaults is also key value, depending on your type, so number, string, entity, all the way down the table. And this will like basically give you an initial default so you don't break your chip. And over here what I'm doing is setting the value on every extra input I make, based on the type. So if this is a number, well, default number equals 0. If this was a vector, well, that would be just an empty vector. And I'm also doing this on the server, I forgot to point out. Actually, no, I'm not doing this on the server, so the server is responsible for actually getting it, so it'll get it before it ever returns nil. So that's fine. Once again, this receive function needs to be called somewhere, and it's, well, I have the manager doing that. So you can see on receive inputs, this is a net.receive. So once again, IOU inputs. That's the ID of my networking junk for the inputs. And we do on receive inputs, which is, another pass-through. So that's what actually calls it. So I had a problem. So previously I was doing manager initialize and make IO on the server just right at the end here, so it would run automatically. Likewise for the client, the pre-initialize, I was just doing it at the end there automatically. However, that was causing problems on the server for basically adding more inputs. So whenever you include a file, the whole thing runs straight to the end. And so the chip wasn't actually able to make any custom inputs because the chip runs up here, and we tried to add an input and it wasn't adding the input. So instead I've added another Mirage function, or like I guess, global function. And so if I collapse all this and come to the end, you can see Mirage initialize. And this isn't actually defined as a shared function because the server and client just do two different things, and I don't really need a placeholder. So on the server, I just calls initialize and make IO on the manager. And on the client, that just calls pre-initialized on the manager. So basically we stick this at the very end of the interface. And so I can add my input and then initialize, and it's gonna make all the inputs for me. Yeah, let's take a look at the little example I added. And it is a pretty crappy example because all it does is tells me whether or not I'm pressing the F key or not, because the F key is an input on the server. Yep, that's it. Also, my gradient is still at 0, 0. The chip is telling me I have an invalid input. It doesn't like Amogus. It told me I was at 103. Let's see. Update value. Wait a minute. Create. I mean, it happens first though, right? Create IO. I mean, we do this first. Number 103. It makes input, right? Okay, that's just straight up not running. Great. Gosh darn it. Input instances. Input instances I'm working on. Go ahead and get the name from that. Yeah, okay. So this straight up doesn't run. But why? Oh, it runs before all this. I have a really big problem. Because this runs immediately, however, I need it to be a bit delayed. So could I do this? Like, function. What was it called? Mirage initialize. And we'll stop that. Manager initialize, manager make IO. So this will be our delayed start, and we need to do it on a client too. Except we're only gonna call this pre-initialize on the manager. Yeah, let's see what happens. Okay, that worked. So for some reason this isn't reacting to the value, so I think it has something to do with this. We'll see. Value. No. Hey, rather than do that, I actually want to wire you to a toggle button. See what happens. That's weird. Oh, I'm just being retarded. The power controller's not linked to the chair. So technically for the last phase, all this section is adding permissions. So if someone doesn't have all the permissions and they get in the vehicle, you send out a permission request. Now the way I did this is copy pasting from MFCS, so it's a little bit overcomplicated, probably. Not helped by me trying to explain it. Or maybe you can't understand, I'm not sure. But that's basically the long and short of it. Okay, so some time has definitely elapsed, and I've come to the conclusion that this really is supposed to be about being able to make simple graphics and have them render. So I'm not going to be doing any super complex input-output systems or networking systems. Really this is enough to just send inputs from the server to the client, and that's where I'm just kind of going to leave it. Also, ideally I wouldn't be sending every single input over every time I want it, every like refresh cycle, but again, it's good enough for now because you can make simple graphics with this, which is all I really wanted. However, the only thing that has changed in the input-output unit is if there is no driver, I'm not going to send, or I'm not going to try to network to anything. Now, I believe I mentioned earlier that we might have to do like stuff with permissions. And the way I've done it here is really overkill because I kind of copy-pasted from MFCS. But to accommodate that, we of course have a new object, requester, and we have a requester answer event, I should say. So normally I talk about the new object I just added and then talk about how I'm using it. However, I'm going to talk about how I'm using it first because it's really something I prefer not to think about. So if we come to the manager's initialize function has been gotten rid of. In fact, the only method attached to manager, so hanging off of its table, is the pre-initialize function. And that has changed a little bit. So the requester has a method called add permission. And we only need two permissions for this to work, material.create and render.offscreen. If you want to know what these are, so if you go into your Starfall settings and go to permissions client, you can see that, well, all of the permissions we can set to no one, anyone, friends only, or only you. So, if someone has their permissions turned off and you want to like give them a chance to use your thing, you gotta do permissions. But the names of the permissions as you give it them, or as you input them, have to match as they show up here. So we can see render off screen, there that is, and material.create. Okay. There's this initialize function, and I want this to ideally initialize coming out the gate. However, if we don't have the permissions, well, then this will never be called. Likewise, my old interchair function. So if we don't have the permissions indicated by a request to get ready, so that'll tell you if you have your permissions or not. If we don't have the permissions, then I don't want to do anything. I also want to have it try and send a request. This might be all very confusing, but basically we're not going to try to initialize or turn the chip on unless we have the permission to do so. So you can see requester get ready comes up in a couple of spots in the entering chair, but also initialize function. And we're not actually calling the initialize function anywhere but on this event whenever the requester tries to get the permissions. Now, before I actually go into the requester, I would also like to mention that we are by default enabling the HUD. And of course, if you're getting in, it's going to be turning it on. So previously, enable HUD was done in the renderer, but we moved it out of here. And the reason we need to enable the HUD is because to actually ask for permission, you actually have to have render enable HUD. Which is kind of weird because enable HUD is a permission itself. And so if they don't have this permission, then you can't ask for permission. It's kind of weird, but anyway. So to recap, we would like to initialize the chip. We would like to have the chip turn on when someone gets in the chair. However, we need to make sure we have permissions first. Okay. So here we go. This is the requester. So things of note, you remember that send request function. We also have a getter, get ready, and ready just indicates whether or not we have permission. Alright, so let's look at this. So there's a couple things that can happen. We could have all the permissions. So just like here, I have every permission set to anyone. So whenever we do send request, I'm keeping a can request boolean somewhere. And basically we can only send one request. So if this is not the first time, then it's just not going to do anything. And I think that's just how permissions work. You can't send multiple permission requests if the first one was denied. So we run it one time, and yeah, that's what setting this to false. So if we try to run it again, it's just not going to run. But anyway, one of two things can happen. We can have all the permissions already, in which case, yeah, ready equals true, and we run that old like a requester event. So it's gonna let the chip run as is. The other case that can happen is we don't have all the permissions we need, in which case we do set up permission request. We give it our permissions table, which, by the way, add permission that just inserts into something I've called permissions, and it takes the perm in there. So permissions is just a table of the name of the permissions you want. And yeah, stuff needed for Mirage and like send request on using the chip. Okay. So you need to add to an event to actually get the result of the permission request. So right before sending the permission request. Actually, I guess it doesn't have to be before, but you send the permission request, but you also add something to a hook to sort of capture the request. So permission request is the name of the StarfallEx hook. Let me see. So yeah, you can see hook's permission request. Okay. So yeah, we add to that hook request answer, which is one of our local functions here. And in request answer, we can set ready to permission request satisfied. So that could either be true and false. You could allow, you can deny it. And we run our event again to say, okay, we have a result. And then we remove this from the hook. So kind of like how we were doing texture writing, we add to the hook, then we remove to the hook in that same function. That's what we're doing here. So this is all that happens if we don't have the permission request, is this right here and this request answer function. Now if we do have all the perms, so this is a function that returns a boolean. So you can see I was using it, has all perms here. What we basically do is we loop through every permission and we check to see if we have it. And there's a like special case here of I remember having an error in MFCS where there was this weird reason attached to it. So there's some filtering, but if for any reason we don't have it otherwise, then yeah, we don't have permission. So it'll return false. So one more time to recap. We look through, or when we send a request, we make sure this isn't the first time we're sending, or we make sure this is the first time we're sending a request. We check to see if we have all the permissions we want or not. If we do, then we're all good and we can just send the hook, broadcast the event to say, yes, you can start up. If we don't, we just send a permission request. And that's basically all there is to it. And this is a really overkill system because it's supposed to let you check for, hypothetically, just any permission you want, because this comes from MFCS and all the different little modules need different permissions. Let me see if I can get it. Yeah, you can see here. So this is just in the graphics part of MFCS. There's a bunch of other things it wants to do, like render view for the rangefinder. If you so much as use hollow no draw, it wants was it entity set render property, so much like stuff like that. So I copy paste it, and it's a bit overkill, but I prefer not to think of permissions too much. I should also mention that we would ideally wait till initializing in the manager to do the things we don't know we should be able to do or not. So your mirror material.create was a permission we needed to make sure we had, so we can't just call material.create out of the gate. We have to wait till initialize. So initially I set it to nil, and once we initialize, then I say material.create. And I believe that should be everything for, accounting for permissions. And again, a bit of an overcomplicated way of doing it because I wanted to have, be able to account for any permission in MFCS, and I copy paste it from there. So let's see what this looks like if I don't have one or all of the permissions. Let's just do one, I guess. So we'll do material.create, and we'll say no one has this permission. Okay, so if I refresh the chip now, here we go. I get in and I see this permission request, and there we go, stuff needed for Mirage, and I can decline this and I'll never get that request again, and I won't ever be able to use the chip until it is refreshed. Let's try it again and allow it, I guess. There we go, and now the heads-up display comes up. And so that actually doesn't set the permission. You can see it's still on no one. It's just overridden for that chip. But hypothetically speaking, if I had all the permissions, it's not going to bother asking because it sees I have all the permissions, so we're good. And we're here now. So I did another video, but I kind of like this chip like quite a bit. I think I'm gonna find some uses for this one personally. And hopefully you're able to, or it's explained the process and how all the systems in this work and why they have to be there. Not a big fan of the input networking, but it works, so that's all it really needs to do. Is no need to be I guess overcomplicate things. Just send one giant table every like fifth of a second, so that's fine. But hopefully you're able to find some use in this, or you're just curious as to how all this works. With that all being said, see you around.